This is Algebra 2 with trig, 8b.2, talking about radian measure. Radian measure is a different unit compared to degrees. It's kind of like feet and inches are different. Radian is going to be different than degrees. It's another way to measure an angle. So we have a circle on an XY axis. A radian is a measure of an angle in standard position whose terminal side intersects an arc of length r. So here we have our circle. So what did this say? The measure of an angle in standard position. So we have a vertex at the origin, like we did yesterday. We have our initial side on the x-axis, and the terminal side is going to intercept the arc at the length of the radius. So you take your radius here and you extend it along the circumference, and that would be considered 1 radian. So if that's 1 radian, then we could have 2 radians and 3 radians and 4 radians as we approach going around our circle. So it's way different than degrees. Just like yards are way different than feet. So if we think about this on another scale, what is pi? We often say that pi is 3.14, but that's not telling us what pi is. What is pi? So if you take your radius, or actually diameter, if you take your diameter and you lay that out on your circumference, that would be 1 diameter. That would be a 2nd diameter. That would be a 3rd diameter. And then we have like 14% left over here. So we have 1, 2, 3.14 is how many diameters fit around every circle. That's what pi is. 3.14, the number of diameters that fit around a circle. So, if the diameter, which is all the way across the circle, fits around a circle 3.14 times, then what happens with the radius? If we take a radius, how many radiuses fit around a circle? Well, we extend a radius. That would be 1. That would be 2. That would be 3. That would be 4. That would be 5. That would be 6. And how much would be left over? 0.28. Good job. So, how many radiuses fit around a whole circle? If 3.14 diameters fit around a circle, and we are going to do half the diameter, which is a radius, now we're going to need twice as many radiuses to fit around a circle. So 3.14 plus 3.14 is 6. 1, 2, 3, 4, 5, 6.28. That's 3.14 and 3.14. So, last one to talk about. How many radiuses fit around half the circle? We have one radius, we have two radiuses, we have three radiuses, and how much do you think we have left there? 0.14. Here we took one radius, two radiuses. We needed more than three radiuses to do half the circle. 4 radiuses, 5 radiuses, 6 radiuses, and we needed more to get to the end. We knew that if we were talking about diameters, we've discussed how that is 3.14. So if we take half the diameter, which is a radius, we're going to need twice as many of them. 3.14 and 3.14 is 6.28. So in other words, the radius fits around half a circle in 3.14, and another 3.14 gives you your 6.28. So 180 degrees is 3.14 radiuses. So instead of calling it that, we call it pi radian, because it's exactly the value of pi. It's not ends at 0.14, but it does the whole value of pi to get to 180 degrees. So pi radian is going to equal 180 degrees, because 3.14 radiuses fit around half the circle. So because the circumference of a circle is 2 pi r, we know that there are 2 pi radians in a full circle. That's what we did here. We calculated there was 3.14 diameters in a circle. When we did half of them, we figured out there was twice as many radiuses in a circle, 6.28, which is 2 pi. It is 2 pi for the completely around a circle in terms of a radian. So we know that 2 pi is going to equal 360 degrees. So degree measure and radian measure are therefore related. 2 pi equals 360 degrees. And if we divide by 2 on both sides, we know that pi is going to equal 180 degrees. Pi radians equals 180 degrees. It's not the number pi. I should really be writing the word radian next to that. It is that many radians around every circle. And a radian is the length of the radius along the circumference. Now, here's a bad habit. Converting. Because when we start to do the real math, we're going to encourage you not to convert. But mathematically, we can convert, and there might be a time or two where it's efficient or needed to convert. But how are these related? Now, when we think about conversion factors, that's what this is going to be. We know conversion factors of inches and feet. There are 12 inches in 1 foot. So if we wanted to figure out how many inches 3 feet had, we would multiply by our conversion factor. And that crosses the feet out, and then we find out we have 36 inches. That's how many inches there are in 1 foot. No, in 3 feet. Sorry. So that's called a conversion factor. These units have to be the same. Well, our conversion factor, if we're converting degrees to radian, we want radian on top and we want degrees on bottom. If we're converting from radian to degrees, we want degrees on top and we want radian on bottom. Because 180 degrees is the same thing as pi radian, 3.14 radian. So let's take 75 degrees and we can give ourselves a little visual the way we've done it before. 75 degrees would be approximately right there. So what radian is that going to be? Well, if we want the degrees to cross out and we want an answer in radian, then we need radian on top and degrees on bottom. Then we have to go through and reduce this. Well, what number goes into 75 and also into 180? Definitely 5, because we have a 5 and a 0. So 5 goes into 75. 5 goes into 7 one time with 2 left over. Goes into 25 5 times. So 5 pi over 36. Oh, well, 15 pi over 36. Thank you. And it looks like we can reduce this by more. So 5 pi over 12 radian. We can abbreviate radian with rad. So 75 degrees is the same thing as 5 pi over 12. Here we have a negative radian. So we're going to put the pi on bottom and the 180 on top. I want the pi's to cross off, so that's how I remember to put the pi on bottom. I want my answer to be in degrees, so that's why I put the degrees on top. Four goes into 4 one time. 4 goes into 180 45 times. So that's going to be negative 225 degrees. So we divided the 4 into the 180, and we got 45. And then we multiplied the 5 times the 45 to get our 225. And this was negative times a positive, made it a negative 225. Here we have degrees, 135. Can you determine which conversion factor to use? If you have to, you can always look up. I want to convert to radian. But I don't even think about it like that. I see that I have a degree, so I'm going to put my degree value on the bottom of the fraction because I want the degrees to cross out. I'm therefore have to put the radian value on top of the fraction because pi over 180 is the same mathematical value as 180 over pi. So you've got to decide which method you need to use. And now I see that they both end with a 5 or a 0, so I know 5 goes into this. 9 goes into this. So 9 goes into 13 one time with 4 left over. 9 goes into 45 5 times pi over. 9 goes into that 20 times. And now I can reduce that one more time, it looks like. And I get 3 pi over 4. And these are radians. So you can reduce this by any little chunks at a time that you want. You shouldn't spend a ton of time trying to figure out the largest number. Most of you will probably default to a calculator to reduce something, but I'm trying to show you that you can do this without a calculator. Here we have 7 pi over 6, so we're going to convert that to degrees. So that means degrees needs to be on top of the fraction. I need to get rid of the pi or the radian, so that has to be on the bottom of the fraction. The pi's cross off. The 6 goes into 180. 6 goes into 18 3 times, and then the 0. So 6 goes into 180 30 times. I know that 3 times 17 is 51. So 51 and another 0 gives me 210, or 510. 510 degrees. So we'll try a few more. If you can stay ahead of me on these, that's good. At home, you can pause the video and work on these two. This is degrees. So I know I need degrees to cross off, so I put degrees on bottom, and I put pi on top. So my degrees are going to cross off, so I have my units correct. I know that 10 goes into both of these. So I'm going to have negative 5 pi over 18. That's radian, just reducing a normal fraction. And then our last one, we're going to put degree on top because we want the answer to be in degrees. We need to put pi on bottom because we need the pi's to cross off. And 10 goes into 180 18 times. So this would be 18 degrees.
Wait, so how?
All right, next we're going to come into something that we did in our previous lesson when we work with drawing our angles. Now, the comment is not to convert. Okay, we don't just simply turn this into negative 60 degrees and draw our negative 60 and then pretend that we did it in radian. There will be some thought in degree because your mind is so dedicated to that, but we'll talk about that. We know that we're going in a negative direction, so we're thinking about negative pi. And we're going to break this up into 3 equal amounts. So when we do that, you can either think about 180 divided by 3 is what number? 60. So that would be 60 degrees to get to this bar, another 60, which is 120 to get to that one, and 180. I broke this into 3 equal pieces. You don't even have to think those degrees. You should be able to break it into equal amounts. So we only want to do one of those equal amounts. So this would be called negative because we're going down, we're going clockwise. Pi over 3 because we're doing one of the 3 amounts. That is our negative pi over 3. 18 pi over 3. The 18 is kind of irrelevant. 18 pi, actually 5. 18 pi over 5. The 5 is what we need to do. We need to break this up into 5 equal amounts. If we're dividing it into an even number, we know that we're going to have half on one side and half on the other. But when we have an odd number, it kind of splits it into 2. It gets a little tricky. But 1, 2, 3 equal slices, 4 equal slices, and 5 equal slices. I broke the pi into 5 equal amounts. Now, what gets tricky here is that we need to be more than pi. 18 over 5 is bigger than 1. So we need to do that again. On that side. So this is going to be 1 pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over 5. Of course, this is 5 pi over 5, which is 1 pi. 6 pi over 5, 7 of those bars, 8, 9 pi over 5, 10 pi over 5, which is how much? How much is 10 pi over 5? That is 2 pi. And we know a full circle is 2 pi. So this would be 11 pi over 5, 12, 13, 14, 15 pi over 16, 17, 18 pi over 5 radian. This next one has 9 for a denominator. Now that's a little intimidating in trying to visually think about where the lines would be, so I have 9 equal sections. So one way you can think about this is, you know that a radian, that we have pi radians for half the circle, for 180. So I'm going to divide the 180 into 9 equal amounts. So each of these slices needs to be 20 degrees. So now when I draw my slices, I'm going 20, 40, 60, 80, 100, 120, 140, 160 to my 180. So now I need to identify where the 7 of those 9s are. 1, 2, 3, 4, 5, 6, 7. So approximately right there.
Is there one more line on the right?
So we flip to the other side. We're talking about coterminal angles. Coterminal angles are what we did yesterday, where we added 360 degrees to our degrees to find other angles that went in the same direction. But now, since we're talking radian, what amount are we going to have to add and subtract from both?
20.
So we are going to add and subtract 2 pi. Because 2 pi is equivalent to a full circle, which is 360 degrees. If we've said that pi is 180, then 2 pi is 360. And we need our units to be the same. So we need one positive and one negative angle coterminal to what's been given to us. We are working in radian. Notice we are not converting into degree and then doing 360 and then converting it back into radian. Don't get into that trap. You want to work with radian and start to see how the numbers work together. This is radian value, so I know I need to add a full circle, because if I think about my drawing, 5 pi over 6, 6 goes into 180 30 times. So I have 30, 60, 90, 120, 150, 180. So I have 6 equal slices. I need 5 of those equal slices. So that would be negative 5 pi over 6. So what I need to do is to find other angles that are also negative 5 pi over 6. So I'm going to go all the way around, which is the full circle. We don't want to use the word 360. We want to call it 2 pi. So we're going to add 2 pi. Well, I can't just add 2 pi to negative 5 pi over 6. I need common denominators. So if my denominator is a 6, what's my numerator have to be so it's still equivalent to 2 pi? 12 pi. Think about this as your denominator. Is a 1. I had to multiply it by 6 to get to 6. So I have to multiply the 2 by 6 to get my 12. And that gives me 7 pi over 6. And wouldn't that make sense? If we came across in this direction, it would have to be 6 over 6 to become a full pi, and 1 more over 6 to become 7 pi over 6. It would be in the same direction. Then we're going to take 5 pi over 6, and we're going to subtract 2 pi. So we are going to subtract 12 pi over 6, because we want to find a negative coterminal that's going to be more negative or larger negative than this guy, which is mathematically smaller. Negative 17 pi over 6. So if you counted your way around, 1, 2, 3, 4, 5, 6, 6 more to get you to 12, which is 2 pi, 13, 14, 15, 16, 17 would put you right there. You could just count your way around it. Over 4, we're going to add 2 pi. 7 pi over 4. We need denominators of 4. So I need 8 pi to be my numerator because it's got to be equivalent to 2 pi. So if my denominator was a 1, I times it by 4, so I had to times the top by 4. That gives me 15 pi over 4. That would be equivalent to 7 pi over 4. And I subtract 2 pi, which in this case we're working with 8 pi over 4, because that's a value of 2. That gives me negative pi over 4. Negative pi over 4 is the same thing as 7 pi over 4, because 7 pi over 4 is 1/4 away from 8 over 4, which is 2 pi. This is 1 less. So we'd have 4 pi over 2, which is 17 pi over 2. And then we have to subtract it. So we're going to subtract 4 pi over 2, because that's equivalent to 2 pi. That gives us 9 pi over 2. All right, but that's still positive, so we got to subtract it again. And that gives us 5 pi over 2. We can move this over here. That would give us 5 pi over 2. And we got to subtract it again, because I still haven't gotten a negative. I subtracted 2 pi, because this is so big. This is many halves, 13 halves. So I've got 4 pi over 2, which is pi over 2. And I'm going to do it one more time. So that's negative 3 pi over 2. That was a little tough. We had to keep subtracting 2 pi from that one, 2 pi from that one, a full circle from that one, a full circle from this one. And there we landed. So we're going to draw our angle, and we're going to give one positive and one negative coterminal. Well, if we take our circle and we break it into sixths, remember that's 180 divided by 6 goes by 30s. So we have 30, 60, 90, 120, 150, 180. That is 6 equal slices. Another 30 would give you your negative 7 pi over 6, because that would be 6 pi over 6, 7 pi over 6. And your angle would go in a negative direction. So what else would go in that direction? Well, a positive 5 pi over 6 would land right there, because 6 over 6 would be here. So 5 pi over 6 would be a positive coterminal. And if we were doing negative, we could either subtract another 2 pi from there, which mathematically just might be easier. Remember, we need denominators to be 6's, so I have to use 12 on top because that's a value of 2. And that gives me negative 19 pi over 6. That's my negative coterminal. Let's see if we can make sense of that. If that's 7, and that would be 12, because that's 2 pi. It's 12 pi, 13, 14, 15, 16, 17, 18, 19. 19 pi over 6. 16 over 3. Well, 3, if you think about 180 divided by 3, that's 60-degree groups. So I got 60 degrees, 120 degrees, 180 degrees. There's 3 equal slices. 30 more degrees, 30 more degrees, so there's 3 equal slices. So I've got 6 going around my whole amount. So that's 6, and then 12, 13, 14, 15, 16. So this is 16 pi over 3. We did 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. We went around the circle several times there. So any of those amounts, 1, 2, 3, 4, that would be 4 pi over 3. 3 over 3 would be 180. An extra 1/3, a fourth one, would put you in the same direction. So that's my positive coterminal. Or my negative 1, negative 2, negative 2 pi over 3 would give me my negative coterminal. So you can just count your way. You can do the subtracting if you want, but if we've drawn it out and given it some detail, we can just kind of count our way around, which is an advantage in the future. Thirds. Well, we already did thirds. Thirds is 60 degrees. So that's 1 of the thirds, that's 2 of the thirds, that's 3 thirds, 4 thirds, 5 thirds. That's 5 pi over 3. So if we went down, how much down would we go? These are all a third, so it would be going down a third. So negative pi over 3 would give us our negative coterminal. 1, 2, 3, 4, 5. 6 would be 2 pi. 6 pi over 3. 6, 7, 8, 9, 10, 11. 11 pi over 3 gives us our other positive coterminal. You could have done it by adding 2 pi to it a couple times. Let's come on down and talk about a little story problem. A record spins at 45 revolutions per minute. Alright, so we're spinning around and around using our record player. Through what angle does a point on the record spin in 1 minute? We do 45 revolutions per minute, so it goes around 45 times. In degrees, that would be 360 times 45. We're going to do 2 pi times 45. So that's going to be 90 pi radians. In terms of degrees, every time you go around the circle is 360 degrees. So that's 45 times 360, and that gives you 16,200 degrees. Much bigger numbers. This is so much more convenient for this situation. And then talking about what we've been doing with our charts, we'll talk about each of these steps real quick, and we'll go over that in more detail in the future. So on a unit circle, we're talking about identifying the radians for each of these locations. So one thing that's going to be easy in terms of degrees is we go by steps of 30, and 30 more degrees goes up to 60, and 30 more degrees goes up to 90, 30 more degrees is 120, 30 more degrees is 150, 30 more degrees is 180, and you can continue going around the bottom. Notice that we skipped this middle one. This middle one would have been in between our 30 and our 60, which would be 45 degrees. That amount again gives us 90. That amount again gives us 135. And you can continue that pattern along the bottom. In terms of radian, 30 degrees goes into 180 how many times? 30, 60, 90, 120, 150, 180. That was 6 total. So this is the 180 divided into 6 equal pieces. This is 45. There are 4 equal pieces. So this is 180 divided by 4, or pi divided by 4. 60 goes into there 3 times. 60, 120, 180. 60 plus 60 plus 60. There's 3 equal amounts. So this angle can be called pi over 3 radian. 90 and 90 makes 180. There's only 2 of them, so that's pi divided by 2. Now this side gets weird. So this would be pi over 3. Another 60 would be 2 pi over 3. This is pi over 4. 2 pi over 4 can be reduced. 3 pi over 4. This is 1/6. This would be 2/6 reduced. 3/6 reduced. 4/6 reduced. 5/6. 5 pi over 6. And of course, this could be called 6 pi over 6, or it could be called 4 pi over 4, or it could be called 3 pi over 3, and every time we just simplify it to pi. You can try to work your way through the bottom with the same pattern. So you see we have our degree values on here. Now we're just going to continue. 5 pi over 6, 6 pi over 6. This would be 7 pi over 6. I got to skip the middle one because those go by 4s. This would be 8 pi over 6, which can be reduced. 3 pi over 4. This would be 9 pi over 6, which can be reduced. That's 7, that's 8, that's 9. This would be 10 pi over 6, which can be reduced. Skip the middle one. And this would be 11 pi over 6. 1/4, 2/4, 3/4, 4/4. This would be 5/4, because it's the center one. They go by quarters. 6/4 reduces. This is 7 pi over 4. One more would be 8 pi over 4, and that's 2 pi. And we did it. We picked all the angles, radian and degrees, to help us know how the unit circle works. Don't worry, we'll practice more.